up, everybody? Welcome to Coffee Hour. It's a Monday. Wake up. It's time to get rolling. Got to make that money. Got to build relationships. Got to grow that business. Got to enhance our knowledge of the National Electrical Code. Got to do all that stuff. Hi, if you've never been to the show before, my name's Paul Abernathy. I'm your host. Thanks for joining me every morning at 8 a.m. for Coffee Hour. I do have coffee today. Okay, there you go, just so you can see it. Have not started in on the Diet Pepsi yet, but I am sure it's going to be a matter of time before I hit it. Had a busy weekend. I hope all of you had a great and productive weekend, spending it with family, enjoying the spoils of life, all that you work for during the week so you can enjoy it on the weekends. If you're struggling, it'll get better. If you're preparing for an electrical exam, it'll get better. You'll get it. Will Paul eventually shave? Yes, he will. Looking like a scrub up here on the camera. But thanks again for joining me and taking the time out of your day to be here to get your week started. And we do it every day at 8 a.m. And you can watch it on all of our social platforms, whatever you're watching now. But you can also watch it over on Fast Tracks Tube as well as fasttracksystem.com. We have added it there as well. And it works seamlessly with the mobile app. So if you have our mobile app, then make sure you get it. If you don't have it, make sure you get it. All right. Hey, everybody. I live vicariously through you folks. I get emails every day, communications, texts, all kinds of stuff from people that are in our program or people that are just wanting to give shout outs to us. You can also send your questions into us. We're a little behind on the Let's Ask Paul, so bear with us. Jeff was sick Friday and he was sick all weekend, so some of his responses to people a little slower. He is better today. So, it's so if you haven't gotten your email yet, you will relax. It'll come, especially if we need additional information. What else? Oh, I most of you know I got a mini excavator. It's a 1.7 ton mini excavator, and if you haven't seen some of the pictures on I don't know where we share them over on TikTok, or we don't do anything on TikTok, but we'll share some stuff, but I don't interact on TikTok. I won't answer electrical questions or do any of that type of stuff on TikTok, but we do still share stuff there. But yeah, man, I dug out about 4 stumps this weekend for a building that's going to go right there beside the house. And dude, these stumps were like 5 feet around and 4. These were, looked like little trees coming out, but the root system was amazing. Anyway, it really did tax that little excavator. So, dude, I'm not even past the 10 to 15 hours of break in, and I've already removed 10 stumps. So I might have worked it too hard, but in figure, a little Chinese excavator, if I'm going to blow it up, I might as well blow it up early, and I need to get those stumps removed so that we can get the building put in and that type of thing. So, hey, might as well burn it up early. Okay? But they are fun to play with. They are really. I've got at least about 13, maybe 12, 13 hours in the seat. And it is true what they say. After a while, it just really becomes an extension. You just do stuff and you don't even realize you're doing it. And your boom goes out, the arm goes out, you go down, you curl the bucket, you pull it back. It just becomes easy. It wasn't at first. It was a bit herky-jerky. But now it's just great. It got pilot controls. So Paul and his toys. But definitely had a good time. All right, so let's do some shout-outs really quickly. Then we'll get into today's lesson. Today's lesson, we're going to talk laundry circuit. We're going to talk dryers a little bit, those type of things. So kind of get some basics out of the way again this morning. As always, if you have topics, this was a topic that was asked about talking about dryers and existing dryers versus new dryers. So as always, I aim to please. So this came from an episode, a submission over on paulabernathy.com asking if I do it. Now, I could have talked about this in a podcast, but I knew that I had a presentation that was kind of okay for it. So I said, what the hell? Let's do the presentation and let's do it on Coffee Hour. Give us an opportunity to learn something. So anyway, where you at? Where you from? Give me some shout outs. Let's get started this morning so we can get this in. Adam, great to have you here. Code Nerds in Force. Thank you, sir. Good morning, Jonathan. Glad to have you here. Good morning, Paul. As always, glad to have you here down in Houston. What's up, new place? You have found the right place. Glad to have you here. Thomas, we'll get you caught up today. Thomas, thank you for joining. Let's see. Marlon, glad to have you here. Frank the Great is in the house. Glad to have you here. Get that week started. Rob's in the house. Rob, good morning. Glad to have you here. David Scott's in the house. David, glad to have you here watching over on our YouTube channel. Appreciate you. Rob's, good morning to all of the Sparkies out there. Good morning, Rob. Glad to have you here. Manny with my lime green Code Nerd hoodie on. There you go. Thanks for joining me. Also, Manny, I didn't know that Vince Delacroce was watching the show on Friday. Great guy. In kind of news that we're gonna get together at the end of the year, and we're going to do a new pool and spa video. And there's nobody better to do it with than Vince, because I mean, and I failed to mention Ryan Jackson also serves on Code Panel 17 and does an amazing job as well. Both just amazing guys. Do way more work on Code Panel 17 than I do. That's for sure. They are the workhorses of Code Panel 17. That's for sure. Would love to have Ryan over on Code Panel 5, as well as Vince as well. But yeah, they do a wonderful job. But Manny, so you saw him, I believe, and Vince reached out to me and said, "Hey, let's redo this video." So I'm excited about that. I always love to see Vince and have him here in the studio, and maybe we can record some podcasts in this podcast studio across the way, as well as do some video. That would be awesome. All right, let's see where we at. Brandon's in the house. Good morning. Jonathan, good morning. Robert, good morning. Let's see here. Brandon, good morning. Hopefully you got your answer, Brandon, over on the mobile app. I think I answered for you. Seattle, I'm going to say it that way. Seattle is the way it sounds. Good morning. Glad to have you here. Tara, I see you in the house. Tara, good morning. Glad to have you here. Joseph's in the house. Sparky's in the house. Glad to have you. Sparky's hitting it up with the wire waffle. I just got a box of wire waffles in. So we will definitely be adding those to the wheel tomorrow. They're already on the wheel, but I'll add a few more spaces. We have them in the clamshell. Get those out to people. There you go. Nepo's yelling out to the Sparky heads. Good morning, Nepo. Or Nepo, however I say it. What's up, Kendra? Hope you're studying hard. Let's see. Joe Mama is in the house. Joe Mama.
Woo, 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 woo. Big dog.
There we go. Let's see here. Adam's boom excavator. There you go. Yes, he was telling me about getting with you in the 2020. Yeah, it's great. Great series. Probably one of the best we did. 6 or 7 parts, 8 parts. Awesome. Just there is no guy. There is no nicer guy in the industry. There's some assholes in the industry, but there's no nicer guy in the industry than Vince. There isn't any. To a fault, he's just so super nice. Angel, what's up? Good morning. Glad to have you here. Crypto's in the house. Good morning, Crypto. Glad to have you here. All right. Well, again, if I didn't call you out, just let me know in the chat. We'll catch you through the day or through the episode. So we're going to get into the lesson today and talk a little bit about laundry, some extra things. What's up, Jay? Good to see you here. Jay's in the house. All right, so let's kind of get to our lesson here. So objectives that we have today, we're going to summarize code requirements for bathroom receptacles. We kind of touched on it last week, but we didn't get too deep. We're going to get back to that and just get that out of the way. Did have some questions people had on that. Code requirements for making load calculations and electrical connection for electric dryers. Okay, should go without saying, but we'll cover that again in case you didn't know. Summarize the code requirements for receptacle outlets in a laundry area. Explain the principles of exhaust fans. Maybe I might touch on that, but everybody knows what the hell exhaust fan is and what it's supposed to do. And in the summary, code requirements for attic wiring, some of the stuff you may see in an attic. Interesting story. It still seems that the vast majority of attics that I went into as an inspector, as a supervisor, was the fact that when people would run their NM cable over the top of the ceiling joists, they would not secure them. They were supported, but they were not secured. You still have to secure them every 4.5 feet. But I would routinely go with a stick. You know, I used to have a stick and go there and reach up and just kind of move it back and forth. And if those cables moved back and forth, then I would write you up. And I'd write you up in 334.30, and I'd say you need to get up there and secure it and support it. Okay? I'm just saying. All right, so we'll talk about that, a little bit of attic wiring. And okay, so talking about the branch circuits to a clothes dryer. Okay, seems pretty simple. People do this 10-3. They run it all the time. Let's see. Finally understand the quarter allowance. There you go, Brad. Yep, I think that was what you had posted in there. So remember, it's a quarter of the volume. Okay, so if it's 2 cubic inches, then it's a quarter of that is 0.50 for each additional equipment ground when you exceed 4. Okay, that type of thing. That's what it is. So whatever it may be, if it's a 12, then again, it's going to be a quarter of the volume. Okay, not a quarter like 0.25, a quarter of the volume for that conductor based on 314.16b. That's what you use. All right. But again, if you wanted to get in on that conversation and learn just like Brandon is, then you got to get our mobile app because we have a chat feature in there. And I did share some pictures of some of the stuff that I dug up excavating. But the chat feature that's in our mobile app is only available to those that are on the mobile app. So once you go to the mobile app, at the very top, you'll see a little registration button. You have to register. Now, you can use all the other features on the app without registering, but if you want to chime in and have a conversation and post images and things like that, then you need to register on the mobile app. It's different from the website. It's separate registration. And then once you do that, you can get in. Here's a tip, though. Make sure the top right on your profile that you turn off the locate GPS thing. Just go down there and select that looks like a little upside down teardrop. Turn that off. That way you don't have to worry about location thing and it's a pain in the butt. Anyway, you'll figure it out. But it's on the mobile app, so give it a check out. All right, so clothes dryers. We all know these things, but again, in case you don't, requires a 12240 volt single phase 3-wire branch circuit. That's 3-wire with ground. Okay, I mean, sometimes the terminologies can be kind of funky from manufacturers that produce wire and cable, right? So we'll say, well, it's a 4-wire. Well, it's a 3-wire with ground. So that's why we say 14.3, 12.3, 10.3 with ground, right? What's up, Tino? Good morning. Got your email? No, you didn't miss anything. We're just waiting for Jeff to get the emails out, so be patient. Let's see here. So it requires a separate 12240 volt. There you go. Directly connections may be armored cable to a junction box or the dryer. Okay. Typically, we're just going to have a cord and plug. I mean, typically that's what you're going to get. Right. Flexible connections allow movement and servicing. Yep. And then if supplied by a receptacle, needs GFCI protection if it is inside of the laundry room. And now, as you know, the code requires that in the laundry, all 125 through 250 volt receptacles require GFCI protection. You'll hardwire it, which you don't see people do, then it wouldn't be a requirement because that requirement is for receptacles, that type of thing in the laundry area. So, anywho, now, subtle changes to the code. Let's go to the NEC really quick and just go to 210.8. By the way, while we're here, since we can, all right, so you see your GFCI requirements. Now, you'll notice that we say laundry area right here, right? And so it says all 125 through 2. So it doesn't matter anymore if that receptacle is within 6 feet of the top inside edge of the sink, although it still would be a requirement here. It's a laundry area that's going to be applicable to the clothes dryer. Okay, but remember, this is dealing with receptacles. That's why it's so important to remember the 125 through 250, because that's not about the branch circuit. That's the receptacles rule, right? Now, when you get down to these other appliances, let's go down here, specific appliances down here, right? And here is where you'll get down and you'll see that it doesn't matter. Still going to require GFCI protection for clothes dryers. Okay, GFCI protection shall be provided for the branch circuit or outlet. What that means is it could be hardwired to a junction box or to a surface box or 4-inch square or whatever it may be. Okay, so the moral of this story is that yes, under the 2023, you're going to have GFCI protection on your clothes dryer regardless. And people say, well, it's going to trip it. No, it's not. It's not going to trip it. What's up, Alex? Glad to have you here. What's up, Adrian? Glad to see you sneak in on us there. Alex, good morning. Glad to have you here. All right. Okay. Let's see. Maybe connected in several ways. Most common method to install a clothes dryer on a branch circuit, y'all do this blindly probably every day, is just run a non-metallic sheath cable to it. A 10-3 with ground, boom. You know what I'm saying? So what does AJ says? How can you not be GFCI protected if hardwired when it says all? Well, the difference, so just to clarify that, Alex, you got to remember how you got to understand how to read the code here. So in this case, it does say all, but again, remember that rule in 210.8a only applies to receptacles. Okay. So without this application, right, let's see, right here under specific appliances, see all this in yellow? So this is or kind of tan. This is incorporated in the 2023 edition, which brings in clothes dryers. So then it doesn't matter whether it's hardwired or not. So again, depending on the code cycle you're in, if you had done a clothes dryer that was, I've never seen anybody do it, but if it was hardwired, then maybe with a flexible cord or something like that, or whip on it or something like that, then you could have gotten around it because it wasn't a receptacle. Okay, that's what this is. But now it makes it doesn't matter, right? It's still going to be required to be GFCI protected anyway. Okay. All right. So common methods is a 4-wire 30 amp receptacle behind the dryer. Yeah. All electrical appliances are required to have a disconnecting means. This is typically the receptacle pull out will qualify as the disconnecting means. That type of scenario typically will work as that. All right. So this is an example in the picture of a hardwired application. I've been doing this for over 40 years. And yesterday, by the way, shout out to my wife, we celebrated our 33rd anniversary. Congratulations, baby. You put up with me for 33 years. Of course, we were dating longer than that, but she survived me for 33 years. And I'm embarrassed to say it. Maybe it might be 34. I don't remember. It was in 91, so I think it's 33. But at the end of the day, congratulations, baby, you survived. All right, so this is a hardwire, and this might go over to a 4-inch square. This might go over to a handy box or whatever. So there you go. Okay, so that might be something that somebody does. I had never done this. Okay. Oh, Jonathan, it was also your birthday. Happy birthday.
Woo, 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 woo. Big dog.
All right. And so this is a method that some people may do. This is kind of an interesting thing for me to show people. This is a transition fitting. So this one, for example, this is not very common, but it comes with EMT, okay? And then it transitions over to flexible metal conduit. And you're saying, can it do that? The answer to that, it can, okay? Yes, if it was hardwired, it would need a disconnect, but you can get away with certain requirements. For example, you can put a breaker lock in the panel, that type of thing, and be compliant with that and still fine. You can get those little breaker locks you can put on the panels for all those different type of things that require disconnect, that type of thing. So There's also features on it depending on the type of appliance. If it has a dedicated off and it disconnects ungrounded conductors, then there are allowances in the code for that unit switching to also qualify as a disconnect. Depends on the appliance we're talking about. Right? But in general, disconnecting means are required. All right, so you take this right here. People say, well, can I do this? And yes. Can I cobble something together, like take EMT, put a fitting on it, then put a nipple on it, and then on the other end of the nipple, screw in a connector for FMC? And the answer to that is no. You may be able to Frankenstein something, okay? I know how you folks think, you know. You might be able to Frankenstein something where you go from EMT, go to a connector, then with a male connector, and then you have a nipple, and then on the other end of the nipple, you screw in the FMC connector, and then change over. Hey, been an electrician for many years, okay? I'm just saying, sometimes things happen, but would not be code compliant because that is not all transitions, all fittings have to be listed for the product it's being used for. So a rigid coupling is not listed for use with EMT and a connector and FMC as a connector on the end, and that actually be the bridge. Okay, I get it, it gets done, but that is not accurate. You should be looking for a specific fitting that allows this transition, but I'm not here to tell you how to do your job. I'm just telling you, you could get an inspector that will gig you because, again, you need to make sure that you use a fitting for the right wiring method you're using. And they do make a transition coupling. This would be EMT to FMC transition because it also might be an EMT to MC. So this fitting right here might have multiple uses, okay? And of course, this is typical what's done right here is going to run, and this could be a cable or it could be EMT, and it runs to a receptacle, right? And this is a 4-wire receptacle, okay? That type of thing. So that's what we've got on that. Hold on for a second. Let me scroll up. Pardon me. All right, where are we at here? Okay, so and I think Tom is pointing out fitting. We'll go there and look at it just to there. Oh, get back. Okay, so here's what Tom is pointing out just for code reference. Thank you, Tom. Right there. Fittings were required. A box shall be installed at each outlet. Source point, blah, blah, blah. Fittings and connectors shall be used only for the specific wiring methods for which they are designed and listed. Thank you.
Woo, 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 woo. Big dog.
That's what I'm talking about. Thank you for giving me that reference. And let's get back to the lesson. All right, so this is probably the most common application. You're just going to put a dryer in there. Typically, the people will put the dryer receptacle up high enough that it serves as the disconnect, that type of thing. This is a scenario where it does not have to be readily accessible. It's accessible, that type of thing. Okay. All right. Okay. So there you go. So this is what's commonly done. All right, let's talk about the load calculations for all those that are doing a load calculation, not just for the branch circuit for the dryer, but obviously we do load calculations as well when it comes to doing the whole house load calculation, right? Whether you're using standard or optional method, you know as well as I do that you're always going to use the optional method in the field because it's going to result in a smaller service, which is still adequate. But on an exam, you need to understand how to do the standard method or we say part 3 method, because that typically is the low-hanging fruit on an electrical exam. They want to know that you know how to do all the little elements under a standard method, right? They want to know that you know how to do the appliances. And when you have 4 or more, that you can apply demand to 75%. They want to know that you understand how to do the 3 VA per square foot. They want to that you can apply a demand to that, all that type of thing. They want to do it. Now, you still have to do kind of demands for the optional method as well, but it seems to be on an exam, they like to give you the standard or the part 3 of Article 220 requirement, that type of thing. All right, so dryers. Dryer elements is connected to the 240. I'm sure you all knew that, the heating element. The motor is and internal lamps are connected to 120, okay, that type of thing. The minimum is 5,000 watts, or the nameplate rating must be used for load calculations. Okay, so if you're doing the standard method calculation for the load of a dwelling, y'all know that 220.54 is going to tell us to use 5,000 or the nameplate, whichever is greater, that type of thing. And then the optional method, we're simply going to use the nameplate. And we get to apply that to our, in the optional method, we get to apply that to demands. First 10,000 at 100% and the remainder at 40%. So we learn that in our Fast Tracks program. You learn that in whatever program you're in. You should be learning that. If you're not learning that in whatever program you're in and they're not taking you through the pieces, then you need to jump out of that program and get to somebody else because they're not teaching you right. Because we want you to be able to retain it. There's our website up there if you're interested in our programs, fasttracksystem.com, that type of thing. So, all right. So load in watts divided by 240 volts determine the required ampacity. Okay, so if we were saying that it was 5,000 watts, divide that by 240, it's going to determine the ampacity requirements. Wiring devices used for dryers are rated 30 amperes for that application. Additional considerations. When supplied by a receptacle, is required to be GFCI protected. We saw that before. I think now, as we learned, it's going to be required anyway. But I got good news, maybe. I don't know. We'll see how it holds. But I got good news because I think in the well, it's not going to matter, is it? In the 2026 NEC, we're going to remove it from the list into 20.8D. It's going to be 422.5, but I think we're removing all of those. Okay, still have a NITMAM to go, so you never know. That's not going to matter because it's still going to be under 210.8A if it's a receptacle. But if what goes through as we think it will, due to compatibility issues, it might encompass all of those, and all of a sudden they disappear. Means not only not going to require it for the hardwired, for example, to microwaves. Still might capture the receptacle in a kitchen, but all those hardwired applications may go away and not have to be GFCI protected, but all receptacle applications will still be required to be GFCI protected. We'll see what happens in the 2026, but I serve on code panel 17 with Vince and Ryan, and we weren't totally convinced there wasn't a potential compatibility issue, even though the manufacturers say it was okay. I don't think we were totally convinced yet. And we hate putting things in the code when we know that there's possible compatibility issues. You know what I'm saying? We should at least kick that can down the road like we did for the outdoor outlets in 210.8F, I believe, where we hit a sunset date to give the manufacturers of HVAC equipment, for example, time to fix their leakage current issue. Nuisance stuff. We should have done this. We probably could have done the same thing and kicked the can down. That type of thing. But we'll see. Probably going to go away. All right. Let's see here. All right. So again, let's see here. Additional considerations when supplying receptacle. Okay. Conductor sizing, overcurrent protection for the dryer, overcurrent protection for the branch circuit. Essentially, you're protecting the branch circuit. Okay. And by proxy, we'll protect the dryer. Okay, but generally our focus on an overcurrent protected device is to protect the circuit conductor. That's what our goal is. And again, if you do it right, inherently it should protect the dryer as well. That type of thing. Now people say all the time, well, wait a minute. On motors, you size the motor larger. The short circuit current, the short circuit ground fault current is larger than what the amps are on the motor. It's because it's designed for that inrush current, and then the motor is going to go back down and operate within the parameters of the conductor sizing and the motor, and everything's going to be fine. It just allows for that sudden surge, and everything's going to be okay. And that's special allowances that you run into when it comes to motors and HVAC applications. Okay, so has nothing to do here. We have to protect that dryer at its ampacity. All right, and of course, grounding frames of electric dryers and electric ranges, the new installations versus existing installation. We've all been in that old house where you go in there and it's got an old circuit that basically has no neutral possibly in it. And you're thinking, okay, what do I do? Or excuse me, no equipment ground. Sorry, no equipment ground. Still has two hots and a neutral, but no equipment ground. And we connected the frame to the neutral, and that was accepted for, until 1996 code. And then all of a sudden now we run a 4 conductors. Okay, two hots, a neutral, and an equipment ground to all ranges and all dryers. That's what we do now. But there was a time when it wasn't. Equipment ground was run. All right, so kind of looking at the scope of a dryer circuit, I'm sure this is not brain surgery for everybody, right? But as you can see right here, this is your terminal in the back. You notice there's no jumper from the neutral over to the frame. This is 4-wire. This is a modern application. So you see the hots coming in, you see the neutral, you see the light and the motor running through there. And of course, here's your heating element. And the heating element is what is connected to the other leg, so that's why it's 240. That's a typical internal circuitry of an electric clothes dryer, okay? And here you see your equipment ground, and the equipment ground is what gets connected by that little strap that they provide, they should provide, that goes over that you actually put on the terminal, okay? Additional considerations. Oops, went the wrong way. We already looked at those. Okay. So clothes dryer for a new installation requires an equipment grounded conductor. A grounded conductor not permitted to ground to the frame. The grounded, this is the neutral, not permitted to ground to the frame in the appliance. We all get that. It's a 4-wire receptacles required. Existing, okay? Existing prior to 1996 permitted the frames of electric ranges, wall-mounted ovens, and surface cooking units and clothes dryers to be grounded by connected to the grounded neutral conductor. I don't know that to be true, Tino. I don't, so I can't say that that is true. I would not think that a connection to equipment ground would actually have any impact on whether or not it works or not. So, but others can chime in, but I don't know that to be accurate or not. I don't know. I haven't tried it. Let's see here. Existing permitted to remain if compliant when it was installed. So that's an important one for folks, is that a lot of people will go to the call and realize that if something was installed in conformance with the code at the time it was originally installed, then it can actually stay. I get this question a lot with things like knob and tube, and I get it. Electricians, we want to rip that crap out. Reality is, if it's still working and it's still in place, then it's still compliant. In fact, the National Electrical Code still has an article dealing with knob and tube, that type of thing. And I get we don't like it. As an electrician, we want to get that out of there, because what ends up happening is, if everything was the same back when it was originally installed, which usually is in open voids and open attics, where they didn't really care about energy efficiency and insulating, then it'd probably be okay, even though the insulation's probably brittle, because of the cycling of the heat and all that kind of thing. And in attics where it gets warm, and but in the wall, knob and tube may be fine, right? Okay. So at the end of the day, you might want to rip it out. But if it was compliant when it was installed, it is still compliant today. I do see a lot. There were some videos circulating on TikTok where the guy says it's a violation to leave knob and tube in. That's not true. Anything that was compliant with the original installation is still compliant today. There is nothing that makes you all of a sudden upgrade a house. Now, when you do a service change, for example, whether you're upgrading, then say go from 100 to a 200, then they may require, if it didn't have a grounding electrode system, they could require it because they're doing an all new service. Everything is new. In many jurisdictions, if it's a like-for-like change, like in Virginia, if it's 100 amp to 100 amps, say you're going from a fuse to circuit breaker, and it's 100 amps to 100 amps, it may not require you to bring anything up to code other than just simply do a changeover from fuses to circuit breaker. Okay, depends on your jurisdiction. But most of the jurisdictions and most people that do new service like that anyway, whether it's a like-for-like or an upgrade, they're going to put, if it doesn't have ground rods, they're going to put ground rods. They're the easiest to put in, that type of scenario. So, again, every jurisdiction's a little different, but at the end of the day, if something was compliant, it's still compliant. The other one that we get from people is the installation of a detached garage where it has no equipment ground, 2 hots and a neutral, it runs all the way out there. And people say, well, that was allowed. There's an allowance under the exception of 250.32. There's an exception, again, prior to these changes in 96 and all that type of stuff, where people said, I don't need an equipment ground out there. When I get out there, I'll just establish a grounding electrode system. But that fails to meet the requirements of being able to clear an overcurrent device in the main house that's protecting those circuits that are going out to the detached garage, that type of thing. So, and it also creates circulating current. So we learned our lesson, right? We learned our lesson to, yeah, the only problem with Annex H, Tom, is it's not enforceable. It's an annex. So it's not enforceable, but great information, but not totally enforceable unless your jurisdiction specifically adopts it. But most annexes, they're just good information, right? But so now we have 4 conductors going to the detached structure, and we have a separate equipment ground. The grounding electrode system out of that detached structure, like a garage, gets connected. The GEC gets connected to the equipment ground that ran with the feeder to the garage, and that gets connected to the enclosure, and the neutral is floating like it should be downstream. Then all of that is compliant. But if it was an old prior to this, you very well could have just 2 hots and a neutral going to that detached structure. And there is an allowance in 250.32, but that's only under conditions that have to be met. And that would be older installations, not newer installations. Okay. All right. Where were we at? Okay. All right. So clothes dryer. So this is a typical new installation. Don't worry about colors, even though this is this is orange for a 10.3. There is no color code in the NEC. It's just something that manufacturers do. So this is just example, happens to be accurate, right? So we've got a red, we got a black, we got a white, and we got that equipment ground. It's ground in the box, so it's on in this metal box. And you see it comes down here to the actual receptacle. And this is a 1430R, 125, 250 volt. It's a device, so that's why you saw when we talk about everything in 210.8, 125 to 250, those A and B, they're talking about receptacles, okay? That's why it states it that way. As opposed to AFCI, for example, where it talks about the circuit, the branch circuit. So it'll be a 120 reference. That's kind of things to remember. Okay. All right. All right. So this happened to be, let's say an old, now ignore the color here, a 10.3 without ground. So this would be the old type of Van Am that might have been run. And this is an example of what they used to do back in the day. All right. And the problem with this is that that this white conductor, this neutral, is going to be carrying the maximum imbalance between these 2 circuits. So while the heat element's going to be balancing out that at 240, you've also got the lighting and electronics and things that'll be using 120. So you are most certainly going to have return current coming back on this neutral. Well, that means that by bonding this to the metal box, and guess what? Then you would be having all of this, okay, energized or potentially energized, that type of thing, okay? So that is something that this would be an old installation. So again, so this example right here would be a clothes dryer. This is a 3-wire, how it would have been done with the strap to the neutral. This is how it would have been done. Right here, okay? And then over here, this is how it gets done on a 4-wire setup, right here. And you make sure that you lift that strap. Now, it could come, the dryer, I think most of them today are going to come set up for the 4-wire scenario, right? But be careful. And why would I be careful? Because you might be putting in a 4-wire circuit, and you may have somebody come along and they have an old dryer. Well, you need to make them aware that if the circuit is new, then it's going to be a 4-wire setup. Then we're not going to do this right here. What's up, Titan? Glad to have you here. Good morning. Hope I'm not missing anybody. Fernando, good morning. Glad to have you here. All right. So there you go. So these are very common setups that you might see. Let's see here. Let me get 210.11c2 requires a 20 amp branch circuit provide for the laundry, at least one. Y'all know this. It says it right in 210.11c2. And it is 1500 VA for those that are doing the load calculation. It's 1500 VA. It doesn't matter whether that's standard or optional method. It's still going to be 1500 VA. And so it's not permitted to have any other outlets on it. So you're not going to put the lighting outlets on it. This is for the laundry. It's just for the laundry. So this will cover the 20 amp receptacle for the washing machine, right? And that type of thing. So covers there. So all 125 volt through 250 volt. You got it off the Chinese market. No, I didn't get Link. This is Link. And I don't know why Link is having a hard time this morning, but it's Link. It was just kind of jittery. I don't know why it's so jittery this morning. It's just like, I don't know. It's hard to say why it was acting the way it was acting, but it is what it is. All right. So anyway, all 120 through 250 volt receptacles installed in the laundry area are required to be GFCI protected. You already saw that. Also, all 120 through 250 volt receptacles within 6 feet of the outside edge of a sink, if you have a sink in the laundry area, would also be required. But at the end of the day, previously, this would have meant that the dryer was not required to be GFCI protected, but the change kicked in, so it's 125 through 250. So regardless of proximity to a sink, all of the receptacles in there. And it was a 2023 that introduced the requirements in 210.8D that's going to kick in the clothes dryer, regardless whether it was hardwired or receptacle. And again, hopefully in 2026, we'll return it back to just the receptacle requirement. We'll see. Still got a nitmam to go. Additional considerations, outlet of device boxes have to be deep enough so that the conductors will not be damaged with installing the wiring device or equipment in the box. Width of the box must also be taken into consideration. This is so true. I get calls all the time from people who say, Paul, is there a minimum bending radius on conductors before they'll be damaged? Now, I know you guys push these things back into the junction boxes. Doesn't hurt the insulation. It's typically fine. It only starts to become an issue. What's up, Beto? I didn't see you. When you bend it, it becomes an issue on the bigger conductors. But the NEC doesn't give guidance unless it's over 1,000 volts. Then it gives you some guidance. Manufacturers can give you some guidance, but when we're talking about 10s, 14s, 12s, 6s, things like that, you're really not. You can bend it unless you're really going after it or really trying to damage it, then it's really going to be hard for you to damage it. Okay. Now, if you start bending a conductor and you notice that the color starts opaquing out and it gets white or creamy colored and the inside starts to really caterpillar in, then you know you've overbent it. But as far as we're concerned here, we want to make sure that the box is adequate so that we can push it, that we have the clearance in the back of the device to the back of the box, all those type of things. We want to make sure that we can adequately, and typically I see people trying to install dryer receptacles in a 20 cubic inch or 18 cubic inch nail-up box, and they try to push it all back in there, and then you're not going to have the clearance in the back, and it becomes an issue. So, be kind to your conductors, by the way. All right. Okay. Now, combination washer and dryer systems are very common in apartment complexes. When I was the head of the inspections for the city of Alexandria, I still lived in Harrisonburg, Virginia. My wife had the home. And the business is there, but I had an apartment up in Alexandria, and it had one of those stackables in there. It's a combination. It worked great. So it takes up about half the floor space of traditional washer and dryer, obviously, because they're on top of each other. So hey, there you go. Some models are one appliance, while others are separate but simply stacked. Okay, so some of them come with the wiring and everything. It's a pre-done configured unit, and some are two separate units that actually stack on top of each other. A gas washer or dryer combination draws about 10 to 12 amps and plugs into a standard grounded type receptacle. Okay, so they might put that in. Now, interesting thing is, as y'all saw, and you've heard me talk about, a dryer receptacle is not required. If you put one in, you have to account for it. and that is the VA nameplate or 5,000, whichever is greater. Or if you do an optional method, it's just a nameplate. You have to account for it. But a dryer is not a required component. The laundry circuit is. Still have to put that 20 amp circuit in there, unless, of course, it's a multifamily building that has separate laundry facilities all on site. It's a whole different allowance. But I want you to just be aware that the dryers are not required. You can still hang them on a yeah, I had to reboot Link. I don't know what's going on. I'd refreshed it. It's just acting funny. But again, you could have a clothes hanger. Okay, so they don't care about the dryer. And the funny is, that's the same thing for cooking. You don't have to account for the range, right? Or any of that. You might have gas, and you don't have to account for it. But if you do have it in your load calculation, then you have to account for it, right? Makes sense, right? Okay, not a requirement. What's up, high voltage? Glad to have you here. All right. Receptacle branch circuit. So we're going to say our branch circuit is B21 for this application. So receptacles in a residential bathroom require special treatment. GFCI required. Y'all know that. AFCI is not required, but it is permitted. If you want to go over and above, all those people that say, hey, I don't do the code minimums, I always go above code. Okay, then you're going to be AFCI in locations that you're not required to be AFCI in. Okay. One receptacle must be within 3 feet of the sink. Y'all have heard me talk about this many times, that I might be able to get away with one receptacle, have a double vanity. If I have a receptacle in the middle, it's within 3 feet of the top inside edge of each bowl, then all I need is one. If I have it on the left side and it's within 3 feet of this bowl, but it's not within 3 feet of that bowl, then I've got to add a second one. Okay. So one may be able to supply the need. If not, you're going to have multiples, right? Cannot be located more than 12 inches below the top of the sink or sink countertop. Okay, so on the side, but it can't be down lower than 12 inches on the side. Now the lighting, so that was the B21. So the lighting in that, the branch circuit lighting for the laundry room, let's talk about that. So the laundry room lighting circuit must be AFCI protected as required in 210.12a. Okay, so that is your AFCI requirements. Y'all probably already do that. Okay. And we can go look at the code. I think it's working. All right, looks like it's working right now anyway. So, and I'm multitasking because while we're talking, I'm checking to make sure that it's loading. So here is our list. And so if you look at the list in a dwelling, okay, in a dwelling, it's a little laggy, but it's there. And 10, 15, or 20 amp branch circuits in here, laundry area, okay? So remember, this is the branch circuits, okay, for the laundry area. Right? AFCI protection. Notice this is not going to require AFCI on the dryer. That's a 240 volt circuit. Let's just say at least right now. Trust me, they're probably already in the works. Okay, that type of thing to come up with an AFCI to be able to do that. You know what? If they can do it, they'll probably do it. And then they'll have somebody push it to get it mandated, I'm sure. I'm just saying, okay? Don't want to be a hater. All right, so a ceiling exhaust fan are installed. Ceiling exhaust fans are installed in the laundry and in the powder room. I don't know the requirement for it to be in the laundry room. Makes sense. Mine doesn't have one, but it makes sense. But would be required for a bathroom unless you have an openable window. That is outside of the NEC, by the way. But most bathrooms that I've seen have an exhaust fan in it. My bathroom actually has 2 exhaust fans, one in the open area and one in the separate little potty area, that type of thing. Okay. It removes excessive moisture. We know what we all call it, right? We call it
a fart fan. Woo, 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 woo. Big dog.
But, that's not really what it is, but my wife would beg to differ. So it's to remove excess moisture, turn it on when you're getting steamed up in the bathroom, that type of thing. It moves that moisture out. Manual, automatic. Mine is just simply manual. Turn it on. Building codes require exhaust to exterior of the dwelling unit. Again, outside of the scope of what the electrician does, except for what we talked about last week. And is that as a contractor, I always exhausted my exhaust fans. It's just part of what our practice was. I don't know what you do. Let me know in the comments. but that's what we used to do. All right, so if we look at this here, this is the lighting branch circuit. Okay, let's see. So we happen to have a panel board in here. Okay, so this is coming in this room here. So let's see here. So we've got our circuits we saw before. Okay, we've got, let's see here. Here's this to the entry. Here's the B21. All right, let's go back down real quick. Let's go back to, all right, so there's B21. This is our receptacle application. All right, so let's go. So here's B21 coming in right here. Boom. So this must be, this is a bathroom. There's the exhaust fan. I would argue that I don't know that this is actually a bathroom. And people say, well, why would you argue that, Paul? Because all I see is this is implying that this is a sink, and there's the receptacles with 3 feet of the basin. That's the receptacle circuit we just saw, right? But I would argue I don't see a toilet. I assume the toilet's going right here, okay? But I don't see it here, so it's just kind of one of those semantic things that I always look at. So we'll assume this is the bathroom, okay? Because that's what it says, that receptacle circuit for that, okay? And then, of course, you have the other circuit, which was B10, which is the lighting, and you see it coming in here, comes into the light box, okay? Drops down here, so we got the switch leg coming down here, but it's also bringing the power down, and then it continues over with a 2-wire over to this 2-gang box, which is going to cover this simple exhaust fan, not a heat light combo, just a simple exhaust fan, pulls hardly nothing. Then it goes over from here, switches over to the vanity light. Okay, you notice it's running 3-wire over to here because it's carrying this, not only the switch, but it's carrying the hot over here. Probably not how I would run that circuit, but anyway, there it goes. I don't like to put anything in these light boxes for junctions. Not the way I would do it. Then it jumps over here with the 2-wire feeding this receptacle out in the hall here, which then powers up to here. Switch legs, seems to switch leg over here. And then, of course, control this light over here. Let's see here. Where else? Okay, come here. It drops over here. And it's extended to the grass. So this is a different circuit. Okay. And this is some attic lighting. Okay. And then you have a switch right here that's controlling this attic lighting. Okay. There you go. All this kind of different layouts. Okay. Okay. All right, so, and oh, by the way, this looks like SP. This looks like symbol for pilot lighting, okay, that type of thing. So you know if you've left the lights on in the attic or not. It's like a little pilot light on it. That's pretty neat, okay? So 210.70C addresses attics and underfloor spaces, utility rooms, and basements used for storage or that contain equipment that might need servicing, and of course, then you have to illuminate it. Requires that the lighting outlet be installed at or near the equipment. It makes sense. It's not going to be at the entrance, although your switch would be at the entrance, right? But your lighting has to be near the appliance if it's being installed for a piece of equipment to be serviced in the attic or crawl. So there you go. And typically the switching would be at, okay? I don't know. That might be a single pole, but I'm thinking, because it's going to talk about pilot in a minute. So while that while that maybe probably is, it's just a single pole switch and everything else. But you see how these over here just say S? So I'm not sure why they wouldn't continue that logic here. You see what I'm saying? So I'm thinking that's a switch with a P, pilot, and I'll explain why in a minute. All right, but typically I don't put a single pole with an SP. I just do an S. And then an S3 would be an S3, that type of thing. Okay, so I don't think that's a single pole. I think that's a pilot light for these attic lights, but that's just me. All right, okay, so that's the rules for the attic or crawl space. Got to have the lighting outlets there. Switched from the entrance. A switch with a neon pilot lamp on the toggle handle glows when the switch is in the off position. Okay, makes it easy to locate the switch in the dark. Oh, okay, so turn it off, it glows, so you know how to find it. Okay, so there you go. So that tells me that was a pilot switch there. Installation of cables in the attic. Okay, remember that earlier when I was talking about how they run non-metallic sheet cable up and above the ceiling joists and they don't secure them properly? You also have issues where you have a scuttle hole or a pull-down access where you have to be either 6 feet or 7 feet away, or the cables have to be protected in the proximity. It's kind of like putting a dome over that entrance. Any cable that's within that proximity is going to have protection, okay? Because it means it needs to be with running boards or guard strips so that nobody going up there is going to step on it or damage the cable. Easiest thing to do is to run it through board holes or run it parallel with the framing members, things like that. And keep it 1.25 inches from the edge of the framing member, and you're going to be okay. If not, you're going to need guard strips. Guard strips could be as simple as a 2x4. As long as it's equal to or greater than the height of the cable, then it is going to protect that cable. Okay. So where do we find these rules? 334.23, which ultimately is going to send you to 320.23. So that's a example in the code where we send you somewhere so that we don't regurgitate the same information over and over again. Obviously, 334 is for non-metallic sheath cable. 320 is for AC cable, but we're going to send you here rather than regurgitate it again in 23 for 334, 330.23, and 320.23. Rather than keep repeating it, that's how it gets done, right? So it says the non-metallic sheath cable installed in the attic must be protected from physical damage. Guard strips are required for cables installed across the top of floor joists or across the face of studs or rafters. Guard strips are not required for cables installed on the sides of studs or bored through the framing member. Okay, as long as we keep what? 1.25 inches from the edge of the board hole to the edge of the framing member. Okay. And I don't know, we're jumping back here. So this is that pilot light that we were talking about. Okay. So single pole switch with a pilot light. Okay. So here it comes in, and you can see the light is across it. So regardless of what's going on with this switch, this little light will stay illuminated. That type of thing. Okay. It's easy to find it in the dark. There you go. Let's see here. Three-way switch right here. Here's a three-way. Y'all all know how three-ways work. But this is also a three-way with a pilot light. Okay. It's a three-way with a pilot light. This is a single pole with a pilot light. All right. And this is, of course, this is a simple concept of the circuit layout for those pilot lights. Okay. This is going to be the general path of the branch circuit, alternating current. And of course, you see this bridge means this little neon lamp is going to stay on all the time. All right. Pulls very little. All right, attics. Now, this is an example or right here. See this? This is what we're talking about, guarding, so that somebody doesn't stepping up there. Again, if it's out of the way, in the eaves, farther away, especially if your attic is like a non-accessible type attic where it's got insulation everywhere, things like that, as long as you keep the cables to the perimeters, then you've got the limitations of the roof and you're not going to be walking on it. Anywhere out where it may be walked on or stepped on, or certainly if it's a scuttle hole within 6 feet of all perimeters, and that includes the rafters as well as the floor area around it, all those areas that's going to need to be guarded, or you're going to bore through it like this. If it's a pull down access, you're going to have 7 feet in all directions that you need to either protect it or run it through bored holes like this. Okay. Now, again, I routinely see these cables just draped across the top of the joists. I get it. People run them quickly from point A to point B, but you need to take into consideration where your access is, whether or not this attic is designed to support a load for storage, because you know the homeowner is going to do it. Okay, you know if they've got an access, whether it's a scuttle or a pull down, you know damn well they're going to be putting stuff up there. So just from an electrician's, not talking code, just from electrician's perspective, it's not going to hurt you to say to the contractor, general contractor, and say, "Do you know what? I need you to leave me some 2x4s. I need you to leave me something that I can put as guard strips." Okay, I'm just saying. The last thing you want is have to come back because somebody's all messing around in the attic, stepping all over your cables and crap like that. Okay, you're with me? I know you're with me. Okay. All right. So let's go real quickly to the Let's go real quickly to the code for this here. All right, so here, and just to show you some general requirements, hold on here. I do want to show you where it states at in 334. for these strips here. Y'all already probably know this, but there's 334 non-metallic sheet cable. And here is in your attic. And right here, oops, 323. Here you go, right here. 334.23. There you go. Accessible attics. The installation of cable accessible attics. Again, accessible attics or roof spaces shall comply with 320.23. Well, we'll click this and go there. It makes it easy. This is AC, but you follow all the same rules. Cables run across the top of framing members where it run across the top of framing members or across the face or rafters or studding within 7 feet of the floor or horizontal surface. The cable shall be protected by guard strips or at least as high as the cable. Where the space is not accessible by permanent means, that means like a scuttle hole, it's not like a pull down access. If that's the case, where the space is not accessible by permanent, then it says the protection shall only be required within 6 feet of the nearest edge of the scuttle hole, that type of thing, okay? So again, the thought is if it's just a scuttle hole access that you're only gonna go up there to put things around, store some light boxes, things like that. If it has an access where you pull down and it has permanent stairs, then chances are that system has been designed to support weight for people who are going to be climbing up into it. Okay, so there's a big difference by putting some light boxes up there. Usually going to put them up there and push them away from the scuttle hole. That means that further out into the attic, that if there's not going to be accessible for people, and people shouldn't be just going through the attic, then it's going to be pumped in insulation, then you probably don't need any guard strips at all. But if you are within 6 feet of that scuttle hole, and you have cables that are running close to it on the top, then you're going to protect them with guard strips, or you're going to run them on the side of the framing member 1.25 inches away from the nearest edge, or you're going to put guard strips. If it is a pull down, then you're going to have to go at least 7 feet out and up. But I will tell you that if you got an attic that is potentially could be finished off, again, then I would run all of my cables down below the framing members or run them along the actual joists, parallel with the joists, and not run into this issue. Okay, that type of scenario. The homeowner will thank you over time. All right, let's get some people on the giveaway and get this started here so we can give away some stuff. Again, Jeff was under the weather, but he's got things going out, so relax. You'll get your email. So let's go. Topics tomorrow. Some calculations tomorrow for some loads. All right, Chris, you're in the drawing for Trade Hog. Congratulations. Hopefully you'll win that. People are loving the Trade Hog. If you haven't checked it out, go to tradehog.net. Tradehog.net and check it out. Give it see if you can break the hog. I don't know if you already have this. Something makes me think you do. If you do, let me know. We'll spin again for you if you already have it. Let's do it again here. High voltage hands is a Fast Tracks tube. If you already have it, let me know. If you already have that subscription, it's an amazing platform, video platform. It is where our new video version of Example. So we're going to spin again. I already know you have that one, Charlie. Hopefully the baby's doing good. Wife as well. All right. So you're going to be in the drawing for the 2023 grounding and bonding course, that type of thing. And I don't think Jeff's got my list, but yeah, I don't think you got that last time. Okay, let's do another one here. Another giveaway. Let's go. We'll be adding a wire waffle. Oh, that's awesome, Charlie. All right, so we have a limited supply of these knives. We got the new knives coming in. I don't know when they're coming in, but that's the little knife, little electrician's knife. I use mine every day. I infused it this weekend to cut off bales, the string off the bales of hay. What did I use it? I used it to cut off. Oh, actually, when I got my excavator, it was wrapped in, pretty little wrap all over things, and I used that to cut the wrap off. Okay, my little electrician's knife. There you go. So you're in the drawing for that. All right, let's do another one. In the giveaway. You're most welcome, Jonathan. Hey, if you don't learn anything today, at least we have a great discussion and very lightly talking about code. It's not always. Let's see. Frank the Great. Ohm's wheel coin. Congratulations. All right. Cool. All right. So all you got to do real quickly, all you have to do, let me show you what you do here real quick. For those that don't have it, I'm going to show you what you have to do to get on Fast Tracks Tube. Okay. All right. So let me go. Let's share this. Let me go over real quickly to show what you have to do. So this is fasttrackstube.com. Okay. And you simply go right here where it says member plan. Go to member plan. All right. Turn this here to black. All right. Go down here and choose the free membership right here. Pick a username, put your name and everything in, email, set your password up, and then go on and submit. And then send us an email and let us know that you signed up, or we'll be looking for it. But if you won your Fast Tracks Tube subscription, that's what you do. You get a free membership first, and you have to wait for us to upgrade you to an annual membership. You see, it's a $99 value. So it doesn't happen automatically. We have to elevate you. So patience is appreciated. Okay. All right. All right. Last one. Let's spin this wheel. Let's see who gets it. That's right. It is like YouTube, but with nothing but electrical videos. So we get rid of all the BS. And we got a lot more videos coming. All right, Paul Montoya, you get the conductor length card registration. All right. Good deal. All right, let's spin another one. Come on now. I feel like another winner. Okay, you're in a drawing for that. Oh, by the way, when you get your emails, folks, this week, or whenever you get them, some have already sent. So might take a couple emails to get some stuff customized for you. All right, but the other stuff like voltage drop cards, things like that, there's no customization. That we just need your shipping information, and we'll cover all that. All right, so what do we got? Carlos. And for those that won courses, we'll give you instructions on what you need to do for your course. But long and short, for anybody that won courses, all all you really got to do is go register an account on fasttracksystem.com, register an account, and then let us know your username. Okay, but that's only for people that actually won courses. And I can actually still tell you who won courses, by the way. And you should get your email anyway from Jeff. But just to make sure I cover it, for those that won courses was Tino H. We got your information. Jay Ormond, you won the 2023 Enhanced Exam Prep. Val and James won the 2023 Grounding and Bonding course. In Mastering the NEC courses, Adam French and Paul Montoya, y'all won those. Those are courses, so make sure that you go have a registered account on our website. So, that way it just saves you some time. And those are just the folks that I mentioned. You're going to go over here on our website and go right here where it says register, right here, right there. Click register, and you'll get a pop-up there, and you got to fill out all this information, okay? And make sure you get registered. It saves us time when you get Jeff's email or whatever, so it just saves time, okay? But those are the people that won courses. Some of the other stuff that was won are engraved products, and that's going to take a couple emails. But don't worry, we're in this for the long haul. Relax. All right. So where was I at? Carlos, I'm sorry. Carlos, let's see here. Martinez, you are in the drawing for Trade Hog. And for those that don't know what Trade Hog is, it is an awesome AI tool that helps you answer questions in the field. Very technical questions, okay? And you can keep asking it follow-up questions, and it'll learn. That type of thing. All right. That's it, folks. I have made it through another day. It is Monday. We got a lot of work to do here. And so I appreciate you all. Look for your emails. Look for things to come out. Y'all have a blessed day. Take care. We will catch you on the next episode of Coffee Hour. Till then, stay safe. God bless. See you tomorrow morning. Peace.